Okay, in this video I'm going to be going over 13.4 compound interest, and I'm going to start with Explain 2, which is on page 684. So compound interest, let's go ahead and get reading, and I'm going to grab a highlighter. So it says modeling interest compounded more than once a year. Interest may be earned more frequently than once a year, such as semi-annually, which is every 6 months, quarterly, which is every 3 months, monthly, which is obviously 12 times per year, and even daily, which would be 365. So if the number of times that interest is compounded a year is n, then the interest rate per compounding period is r over n, where r is your annual interest rate. So that's if, the bank says I'll give you 5% interest, that's what your rate is. The number of times that the interest is compounded is, compounded in t years, so t being the number of years and n being the number of times per year, is nt. So the exponential growth function becomes this formula here. So it's really important that you understand what each one of these represents. So P is your principal or your initial amount. So initial amount. R, we said, was your rate. N is the number of times that it's compounded. Number of times compounded. And then T is the number of years. So when you're reading this, let's identify it. So it says a person invests $1,200 into an account. That's your initial amount. And it earns, or in an account that earns 2%, so that's my rate. And it says earns annual interest compounded quarterly, so quarterly. We're talking about how many times per year. Well, quarterly, there's 4 times per year. And it says find when the value of the investment reaches $1,500. So when will my total amount equal $1,500? So if I plug these in, this is what it's going to look like. So my V of t here is going to be 1,500. My principal amount, we said, was 1,200. My rate is 0.02. The number of times per year, that n is 4, so we plug it in both spots here for n. And then t, that's what we're trying to do. We're trying to find when, so after how many years will this total equal that. So I would have the 1,500 equals 1,200 times 1 plus 0.02 over 4 times 4t. And now the book is saying use a graphing calculator to find where these two functions, so graph y equals that, and see where they intersect. And if you look at the graphing calculator here, it says x equals 11.185. So it will reach that amount in approximately 11.2 years. So let's see if we can do the same thing for part B. So a person invests $600. So 600 is my principal amount in an account that earns 6.25%. So if I write that as a decimal, remember, move your decimal place, and I get 0.0625. And N, it says semi-annually. What does semi-annually mean? So semi-annually at the beginning said that it was 2 times per year, or if you think about, I think about a semicircle, it cuts it into 2, so it's twice per year. Find when the value will reach 1700. So let's plug these in. I'm going to have 600 times 1 plus my rate, which we found to be 0.0625, over my 2 times per year. And if we do some math, let's use a calculator and simplify what's on the inside here. So 600 is still here, 2t is still here, and let's figure out what 1 plus 0.0625 divided by 2 is. So using a calculator, I got that this is 1.03125. And it says graph the function on a graphing calculator. Also graph the line y equals, well, since this whole thing has to find out when it equals 1700, we're going to graph the line y equals 1700 and find where they intersect. So using the book's graphing calculator here, we find that that's at x equals 16.92229. So we have that the function is 1700 at approximately 16.9. So the investment reaches 1700 in approximately 16.9 years.